do a little bit more practice with finding angles and sides in right triangles. So big thing we want to remember is SOHCAHTOA. We talked last day that sine of any angle is equal to opposite over hypotenuse. Cosine ratio of an angle is equal to adjacent over hypotenuse. And tangent of any ratio is equal, or any angle, sorry, is equal to our opposite over adjacent. So, notice that each of these ratios consists of an angle and two sides. So as long as we have two of those pieces, we can find the third side using those ratios. So if we want to, in example number 1, find the value of x, so we're looking for a side. We have to work with the angle that we're given, and remember we only use the acute angles, not the 90 degree. The 90 degree will not work for some of our ratios, so we always want to use our acute ones. So for part A, we're going to set up our ratio. We always want to start with our initial ratio. We know that we have, or we're looking for our opposite. We have our hypotenuse, which means that we're going to set up our sine ratio. And sine of 32 is equal to opposite over hypotenuse, or 14.3. So taking our 14.3 over to the other side and multiplying by sine 30, we know that we are going to get, rounding to the first decimal place, we know that x is equal to 7.2. We make sure our units are on there, and we just verify, look it over. We know that we've set it up right. We have sine opposite over hypotenuse, and we've rearranged appropriately. We can put a little dot on here if we wish. Remember that rounding to one decimal place for sides is our general formatting. Okay, so we're going to round to one decimal place each time. Now, our second one, we don't have x here, should be over here. So taking a look again at the angle that we're given, and we have our opposite side, we're looking for our adjacent side. So we have to use tangent. Tangent is working with opposite and adjacent. So opposite in this case is 23.4. Adjacent is what we need to figure out. So now x is on the bottom. As we've talked about in solving equations, we don't want x to be on the bottom. We can't solve for it where it is. So we're going to take it over to the other side where it becomes multiplying. Now we're going to take that tan of 76 over to the other side so that we can solve for x. When we do this, we want to make sure that we are rounding to our one decimal place again, and we get 5.8. We make sure our units are on there. So x is equal to approximately 5.8 centimeters. Example number 2, now we need to find an angle. So again, we have to focus on the angle that we need to find to figure out which ratio to set up. So here we have our adjacent and we have our hypotenuse, which means that we have to use cosine. Now theta is used in general for missing angles. So cos of whatever angle this is, which is represented by theta, is equal to 12 over 13. Now 12 over 13 is going to give us our ratio. We could find this number now and then do our inverse cos, but we want this to be as precise as possible. So we're going to do our inverse cos. Remember we talked about to go back to an angle, we do our inverse cos, which is usually above our cosine button. So theta is a measure of an angle. We're going to put in there -1, cos -1, or inverse cos, bracket 12 divided by 13 to get as precise an answer as we can. So 12 divided by 13, and then we do our second cos, and we round angles to the nearest degree. So rounding this one, we get 23 degrees. Now, just a reminder as well that if you're not getting the right answers, make sure that your calculator is in degree mode, because you will not get the right answers if it's not in the right mode. And part B here, we want to find out theta again. So looking at what sides we have to work with, we have our opposite, we have our adjacent, which means that we need to use our tangent ratio. So tan of theta is going to be equal to 7.3 over 5.7. So theta is going to be equal to our inverse tan of 7.3 divided by 5.7. And we do our inverse tan. Theta has to be equal to, rounding to the nearest degree, is 7 degrees. So 7.3 divided by 5.7. And sorry, double checking, you should be getting 52 degrees. Okay, so again, just going over how to find sides and angles in or using tan, sine, and cosine ratios. This is a major part of trigonometry, so we really need to make sure